Hello students, welcome to the subject of complex variable and partial differential equation. Myself Dr. Ankit Acharya, and in today's lecture we will discuss about very important topic, Langrage linear equation. Okay, and this is very important topic of this chapter, first order partial differential equation. So let's see how we can solve Langrage linear equation and what is exactly Langrage linear equation. In first order partial differential equation, we know that we have five variables, most probably x and y, where x and y are independent variable. Z is a dependent variable depending upon x and y. Okay, and p and q, where p that is equal to del z by del x, and q, small q, that is equal to del z by del y. Okay, so first order partial differential equation, generally we have f of x y z p q that is equal to 0, this type of differential equation. Now a first order partial differential equation is called Langrage linear equation. Okay, Langrage linear equation, or sometimes it's called Cauchy linear also. Okay, Cauchy linear. If it is of the form, this is the Langrage linear equation form, capital P into small p. Okay, plus capital Q into small q, that is equal to R, where capital P is a function of xy, capital Q that is also function of xy, and capital R is a function of xy z. Okay, so this is the Langrage linear equation where capital P into small p plus capital Q into small q that is equal to R. As for example, this type of example, you can see that xy into p plus y square into q that is equal to xyz, and second example I mentioned here, x square p plus y square q that is equal to sine xy into z square. Okay, so you can easily understand that these are two examples of Langrage linear equation. Now next I want to explain that how we can solve this type of Langrage linear equation. So that is our next process. Okay, so here you can see that solution of Langrage linear equation. Okay, so a partial differential equation of the form capital P into small p plus capital Q into small q that is equal to R, where capital P, Q, R are function of x, y, z, or sometimes it's called constant also. It's called Langrage linear equation. Okay. Now working rule to solve this type of differential equation. This is our first step. Okay. Write down the auxiliary equation. What are the auxiliary equation? Dx by capital P that is equal to dy by capital Q that is equal to dz by R. Okay. Remember this auxiliary equation, important. Dx by capital P that is equal to dy by capital Q that is equal to dz by R. So first step is very simple. Now important thing is second step. Okay, what is my second step? Solve the above auxiliary equation by the method of grouping or multipliers method. Okay, or sometimes we have to use both the method. For one solution we have to use grouping method, and for another solution we have to use multipliers method. Okay, because from this auxiliary equation we want two independent solutions. Okay, two independent solutions, u is equal to c1 and v is equal to c2, where c1 and c2 are arbitrary constants. Where grouping method is quite easy because we have total three equation, dx by capital P that is equal to dy by capital Q. Okay, and that is equal to dz by R. So we have three equations. Grouping method means you can compare any two equations. Suppose you can compare dx by capital P that is equal to dy by capital Q. Okay, from that maybe you can get first solution very easily. Now second solution, for a second solution you can compare another two equations. Okay, either you can compare dy by q that is equal to dz by R, or either you can compare dx by p that is equal to dz by R. Okay, and from that equation you can get second solution using grouping method. But the condition is, this condition is very important. Okay, because you can integrate only when with dx you have only function of x. Okay, with dy you should have only function of y. Okay, with dz you should have only function of z, otherwise you cannot integrate. Okay, so that's why in some of the example grouping method does not work. and that's why we have to use multipliers method. Okay, now what is multipliers method, how we can use multipliers method in such type of example, that I will explain in particular that example. Okay, so you can easily understand. So let's try to solve some of the important example using the grouping method. Okay, so let's solve our first example for Langrage linear equation. Here you can see that yzp minus xzq, that is equal to xy. Okay, so compare this equation with capital P into small p plus capital Q into small q, that is equal to R. So capital P, what is capital P? Capital P, that is y into z. What is capital Q? Capital Q, that is minus x into z. And what is capital R? Capital R, that is xy, x into y. Okay, so what are my auxiliary equation? Auxiliary equation, we know that dx by capital P, that is equal to dy by capital Q, and that is equal to dz upon capital R. Okay, so dx upon yz, that is equal to dy upon minus xz. Okay, and that is equal to dz upon xy. Okay, dz upon xy. Now you can compare any two equation. Okay, so I just compare first two equation, dx upon yz, that is equal to dy upon minus xz. So just I write first two equation, dx upon yz, that is equal to dy upon minus xz. Am I right? Just in denominator we have yz and minus xz. Okay, so correct, yz and minus xz. Now you can see that first of all z can be cancelled out from both the sides. So now we have dx upon y. Okay, that is equal to dy upon minus x. And now from this equation I can write this is x dx plus y dy, that is equal to 0. And now you can easily integrate. Okay, integration. Okay, so that's why the first solution I will get x square by 2 plus y square by 2, that is equal to some constant c, and that's why I can write x square plus y square, that is equal to 2c, call it 2c, that is equal to c1. So this is my first independent solution, I can say. Okay, and now what is my next two equation? Okay, I can compare first and last. So dx upon yz, that is equal to dz upon xy. So dx upon yz, okay, dx upon yz, that is equal to dz upon xy. Correct? Let me show you. Right, xy, here yz. Okay, so correct. So now here you can see that y will be cancelled out. Okay, y will be cancelled out. So you have only dx upon z, that is equal to dz upon x. Okay, and from this equation I can write x dx minus z dz, that is equal to 0. And now integration on both the sides. So you will get x square by 2. Okay, minus z square by 2, that is equal to some constant alpha. Okay, and that's why x square minus z square, that is equal to 2 alpha. Okay, and call it 2 alpha, that is equal to c2. Okay, or alpha 2, whatever you can write. Okay, so this is my second independent solution, x square minus z square. So what is my first independent solution? X square plus y square. Second independent solution, that is x square minus z square. So I can write the general solution. Okay, the general solution, that is f of uv. Okay, f of uv equal to 0. What is u? U is x square plus y square. Okay, and v is x square minus z square, that is equal to 0. Okay, so using grouping method you can easily solve example. Okay, quite easy to solve using grouping method. Let's take one more example. Okay, here you can see that what is my capital P? Capital P, that is x square. What is my capital Q? Okay, capital Q, that is y square. And what is capital R? Capital R, that is equal to z square. So dx by capital P, so that is x square, dy by capital Q, that is y square, and dz by capital R, that is z square. So compare first two equation. So dx by x square, that is equal to dy by y square. Now integration of 1 upon x square. Okay, integration of 1 upon x square with respect to x. Try to understand very carefully, especially diploma students. Okay, integration, this is exactly something like the integration x raised to minus 2 dx. Okay, and the formula for x raised to n, that is x raised to n plus 1 upon n plus 1. Okay, integration of x raised to n, that is x raised to n plus 1 upon n plus 1. So that's why this is x raised to minus 2 plus 1 upon minus 2 plus 1. Okay, so minus 2 plus 1 means minus 1. So this is exactly minus 1 upon x. Okay, so that's why when we integrate on both the sides, left hand side we will get minus 1 upon x. Similarly, right hand side we will get minus 1 upon y and plus c1. Okay, plus c1. So I can write 1 upon y minus 1 upon x, that is equal to c1. Okay, so this is my first solution, 1 upon y minus 1 upon x, that is equal to c1. Now compare other two equations. Okay, other two auxiliary equations. I can compare dy by y square, that is equal to dz by z square. Okay, so dy by y square, that is equal to dz by z square. Okay, and that's why dy by y square, the integration of 1 upon y square, that is minus 1 upon y, just mention you are integrating on both the sides. Okay, so just write down the full sentence, integration on both the sides. So that's why minus 1 upon y, that is equal to minus 1 upon z, that is equal to c2. And that's why 1 upon z minus 1 upon y, that is equal to c2. So this is second independent solution. So what is now your general solution? General solution, that is f of 1 upon y minus 1 upon x and 1 upon z, okay, minus 1 upon y, that is equal to 0. Okay, so this is my general solution for this example. Now interesting thing is that how we can solve example using multipliers method, because as I told you that in some of the example we cannot use grouping method, because there are some conditions to solve example using grouping method. With dx you have only function of x, with dy and with dz you have only function of y and z, then only you can integrate the function. Okay, here you can see that for this example, what is your capital P? Capital P, that is z minus y. Okay, what is your capital Q? Coefficient of small q, that is x minus z. And what is your capital R? Capital R, that is y minus x. So what are my auxiliary equations? Auxiliary equations are dx upon z minus y, that is equal to dy upon x minus z, that is equal to dz upon y minus x. Okay, first of all these are my auxiliary equations. Now very basic concept which you already studied from your lower standard. Let me show you how we can use multipliers method. So first of all, we know that suppose this type of fractional relation you have a upon b upon c upon d, that is equal to e upon f. Suppose we have this type of fractional relation. Okay, a upon b, that is equal to c upon d, that is equal to e upon f. And then suppose addition of the denominator, that means suppose you have b plus d plus f, that is equal to 0, then always addition of numerator, that means a plus c plus e, that is also 0 always. Okay, so let's solve this example. Okay, as I told you that we can use multipliers method. How we can use multipliers method? So capital P, that is equal to x into y minus z. Okay, I just write all this term once again. Capital Q, that is equal to y into z minus x. And capital R, that is z into x minus y. Okay, so dx by capital P, auxiliary equations are dx by capital P. So dx by x into y minus z, that is equal to dy upon q. So y into z minus x, and that is equal to dz upon r. So z into x minus y. Okay. So first of all, you can easily understand that this example we cannot solve using grouping method. Okay, because here in denominator we have x y z, here also we have x y z, in denominator of dz here also we have x y z. So it's not possible to solve this example using grouping method. So that's why we have to think about multipliers method. Now you can see that in this example, in denominator, the addition of the denominator, that means what is the addition of x into y minus z plus y into z minus x plus z into x minus y. Clearly we can see that the addition of these three terms is 0. Okay, because see xy minus xz, here we have yz minus yx, here we have zx minus zy. Okay, so this xy minus xy, this is minus xz plus xz, this is yz minus yz. So addition is 0. Okay, that means what, using multipliers method you can say that addition of the numerator, that is also 0. Okay, so that's why we have dx plus dy plus dz, that is equal to 0, and when we integrate this equation we get x plus y plus z, that is equal to c1. Okay, x plus y plus z, that is equal to c1. Clear? And now similarly, now I can write the same auxiliary equation with this manner. Okay, dx upon x, in bracket I have y minus z, dy upon y. Okay, in bracket in denominator I have z minus x. Okay, z minus x, and dz upon z in denominator. Now I have, okay, x minus y. Correct? X minus y. Now once again you can see that the addition of the denominator, that is 0. Okay, see, in denominator we have y minus z plus z minus x. Okay, and plus x minus y. So once again addition is 0. Okay, y minus y, this is plus x minus z plus z. So addition is 0. So once again you can say that the addition of the numerator, that is also 0. Okay, and that's why I can write dx upon x plus dy upon y and plus dz upon z, that is equal to 0. And now when we integrate this equation, we have log x plus log y plus log z, that is equal to log c2. We know that integration of 1 upon x with respect to x, that is log x. Similarly for integration of 1 upon y and 1 upon z. Okay, and because of logarithms have some properties, I can say log xyz, that is equal to log c2. Log will be cancelled out from both the sides. So xyz, that is equal to c2. Okay, clear? So that's why we have two solutions. First solution, that is x plus y plus z, and then x y z. So f of the general solution is x plus y plus z and x y z, that is equal to 0. So this is my general solution for this particular example. Okay, so Langrage linear equation is very important topic. Okay, some of the example we can use grouping method, in some of the example we have to use multipliers method. So try to solve all types of example, in particular in this method. Okay, so thank you.